Hi, everyone. Thank you for joining us today and welcome to Steam Management's webinar series, where we do deep dives on topics once a quarter throughout the year. In today's session, we'll be exploring various boiler fuel options to help you make informed choices for efficiency and sustainability. Our host is Chase Bean, Steam Management's Director of Engineering and Business Development. He has over 15 years of experience in engineering, project management, and business development in the energy sector. He is also a registered professional engineer in multiple states and holds PMP and CEM certifications. I'll be monitoring the chat, so feel free to ask questions at any time during the presentation, and we'll answer as we go. Also, keep an eye out for a few polls that will launch throughout the session. Thanks again for tuning in. We're ready to get started, so I'll pass the mic over to Chase Bean.
Thank you, Ashley. I appreciate it. Welcome, everybody. Thank you for joining. We are Steam Management. We're an EPC energy efficiency contractor with sustainable solutions. We focus mostly on steam systems in a variety of markets, and mostly retrofitting and replacing existing or equipment in existing systems to improve efficiency. And we're happy to have you. I did want to put this disclaimer, and I'm going to turn my camera off. Just wanted that for the intro, but I will turn it off now. I didn't want to put this disclaimer in. As I was building this presentation, I don't want to, or I kind of came to the realization that I don't want to look like we're touting any particular fuel type. We don't endorse or advocate for any specific type of fuel. So I'll just read it. So this presentation provides an overview of regulatory landscapes, financial incentives, and strategic considerations related to boiler fuels. It is intended for educational purposes only. We do not endorse or advocate for any specific type of fuel. Decisions regarding boiler fuel choices should be based on individual circumstances, regulatory compliance, and financial considerations. The presentation is based on our impression of the current general boiler fuel landscape as it pertains to the United States as a whole. So for specific recommendations, please consult with SMI to discuss your application. So feel free to reach out to me with any specific applications. For educational purposes, I intended to kind of make the landscape a general kind of informational presentation, but in reality, we all know that's not the case. Different regions have different incentives and regulations and fuel costs. And so it's always a new puzzle in each scenario. But okay, so saying that, here we go. Today, our presentation learning objectives. Why does fuel type matter? Types of boiler fuels, which we'll go through in 3 different sections: fossil fuels, renewable fuels, and alternative fuels. Those are not hard, fast classifications as we go through them. It's just how I classified them for this presentation, just so you know. Choosing the right fuel, and then at the end we'll have a comparison summary and some time for questions, as well as some time for questions along the way. So why does your fuel type matter? First of all, and probably the biggest factor, at least historically, for selecting a fuel type is your cost. That's initial cost and operational cost. This is a pie chart of the typical operational cost for a natural gas steam boiler. So I don't know exactly what type of boiler they had in mind when they came up with these figures, but I'm picturing just, your standard fire tube Scotch Marine type boiler. And you see there that fuel cost is 45% of the cost. So it's significant. And fuel costs can overtake initial costs very quickly, in a typical boiler. Why else does it matter? Regulatory landscapes and financial incentives. So this is kind of specific to federal regulations and financial incentives. So federal incentives like the investment tax credit, the modified accelerated cost recovery system, which is an accelerated depreciation program to kind of take advantage of the tax advantages of accelerated depreciation of equipment. And then Section 179D, which includes tax incentives for building owners to make improvements to their systems, including their utility systems like their boiler system. In 1963, the Clean Air Act was established. This gets revised every few years. I believe there were some new standards that came out in April of this year. Under that, you will hear about things like the NSPS, which stands for New Source Performance Standards. Those are basically the emission standards for pollutants. MACT is Maximum Achievable Control Technology, which focuses on hazardous air pollutants. BACT is Best Available Control Technology, which focuses on criteria pollutants and hazardous air pollutants, HAPs. And then MATS is the Mercury and Air Toxic Standard, which is kind of the big ticket item that is kind of making a lot of coal plants not cost effective anymore because of the stringent, or that's a relative term, but the stringent emission standards that are being levied on coal systems. Backing up a bit, I guess, just so you know, HAPs, hazardous air pollutants, those are generally concerning large industrial plants and utility plants. So that's where you see MACT the most. And then criteria pollutants are known air pollutants that can come from a variety of sources. So can come from automobiles, that it's kind of more small scale use. So that's where you're seeing the BACT terminology more. So in addition to federal legislation and incentives and tax credits, there are regional policies and incentives that are driving transition. So just some examples, utility incentives, for one, are available across the country and varying amounts for carbon reduction, and those significantly enhance ROIs for efficiency improvement. Sometimes, in some cases, completely offsetting the cost of some measures. So they particularly drive some of these projects. And then some other examples, there's the RGGI, which is a cooperative of states in the Northeast that are intent on reducing carbon emissions. There's state-specific policies. I won't read all of those. And then, even more locally, there's an anticipated carbon tax in the Boston greater area that could nearly double gas costs for some users. So these things obviously have a heavy hand in your fuel selection process. Ashley's got a poll there. Let me back up. Okay, so there should be a poll in the chat. It did not pop up on my screen like it normally does, so you might have to go to the meeting chat to find it. And you can participate in that. Also, feel free to ask any questions along the way. Ashley is moderating those and will kind of interrupt me, and I'll address those as we go. So types of boiler fuels. So we'll go through a bunch of different types of boiler fuels and kind of briefly talk about each. Natural gas is composed primarily of methane, which is formed like other fossil fuels from decomposition of organic matter. So everyone's familiar with natural gas. It's probably the most abundant boiler fuel out there, and it has an HHV of 1,020 BTUs per SCF. That's a average number that can vary with gas composition, and then an LHV of 910. So HHV, I'll list this for each fuel, and just so you know, HHV represents the total amount of heat released when the fuel is completely combusted, including the latent heat of vaporization, and LHV does not include that. And LHV does not stand for latent heat of vaporization. It stands for lower heating value. HHV is higher heating value. Pros of natural gas: it's clean burning, relatively speaking, compared to other fossil fuels. High efficiency. So the if you think of condensing hot water boilers, that's pretty much the highest efficiency you can get on a fossil fuel fired boiler type of heater. Um, it's also cost effective. Natural gas is commonly going to be your cheapest fuel source, and is commonly going to be significantly cheaper than electricity as a heating source. The cons are carbon emissions is still a fossil fuel, so you have carbon emissions. Infrastructure dependence. Some facilities just don't have natural gas access, and so they will commonly choose a different type of fuel that can be transported, like fuel oil, propane, biomass, and we'll talk about those later. Price volatility. There's you are subjected to the fluctuations in the market prices. And then it's a non-renewable resource because it is a fossil fuel. Liquid natural gas is basically natural gas that's been cooled to very low temperatures so that it can be converted to its liquid form, which makes it easier to transport. Liquid natural gas is about a 600th of the volume of natural gas, so you can get a lot of gas moved quickly, even though cooling the gas to those types of temperatures presents a lot of challenges. This is generally not applicable for um, your average person that's concerned about installing a boiler. This is more concerning shipping natural gas between countries and things. There are facilities that are right near a liquid natural gas processing facility that maybe are using liquid natural gas, but it's really just a means to transport natural gas. Compressed natural gas is kind of the same thing, and it's just compressed to a really high pressure, not liquefied, but significantly reduces the volume, and so you can transport more gas, on a truck or a ship or whatever. And I've actually been in a manufacturing facility where they were manufacturing compressed natural gas spheres. They don't even use like your traditional tanks usually, like you think of a cylindrical tank with dished ends, dished heads on the ends. It's actually just a sphere so that it can be as strong as possible, at least the ones that I've seen. And I saw those being welded. It's a very specific weld. It's machine welded so that everything is very consistent. And I just visually, from what I remember, I mean, the metal was probably like 5 inches thick on those things. So it was really a strong vessel for the application. The next fuel oil. So most commonly number two fuel oil you'll see. It's also known as heating oil or diesel fuel. Number six fuel oil you still see a lot, known as residual fuel oil or heavy fuel oil. Number six is kind of getting phased out in most areas. It's a little bit dirtier, not cost effective. There's environmental concerns with storage. And it has to be heated. I'm kind of getting ahead of myself because these are the cons on the next page. But number two fuel oil is still pretty common. It's also a good choice for a backup fuel, and a lot of facilities are still using it for that. Pros: high energy density, reliability, because you are able to kind of control your supply of fuel by storing it on site. Storage and transport, versatility, can be used in most applications, can be cost effective. Usually is going to be more expensive than natural gas, or propane in a lot of cases. And it is widely available. You can pretty much use fuel oil anywhere in the United States. I'm not aware of anywhere that has no access to fuel oil because it's just something that could be trucked in. Um, Cons, carbon emissions, again, it's fossil fuel, price volatility, maintenance requirements, storage risks. So this is a lot of it is concerning the tanks. They can leak and they can contaminate groundwater. Um, Health risks, and it's a non-renewable resource. Also, in the case of number six, fuel oil, there's significant heating requirements just to be able to use it. It has to be warm in order to be atomized, and also just for storage. The next fuel is coal. So coal is a sedimentary rock that forms from the accumulation of physical and chemical alteration of plant material over millions of years. A process called coalification, and it occurs in stages. So the types on the bottom, those are the different types of coal. They're in order as the process of how they're formed, but I do go through the stages of the process on the next slide. Lignite is kind of the least energy dense type of coal. It's the least formed type of coal. And then you go to subbituminous, bituminous, and then anthracite. So you can see the HHV per pound increases as you go along there. So this is kind of the process of formation of coal. So you have plant material goes to peat, goes to lignite, and then the types of bituminous, and then peat source as well. I just recently saw a video of a guy in Scotland manually making bricks out of peat to burn in his home. So I wasn't really aware of that, but I thought that was interesting. So what are the pros and cons? Pros of coal is a high energy density. It's abundant. The cost historically has been very low, and it's still low for fuel compared to a lot of fuels. Um, it's still low specifically for the fuel, not for the total operation. That's what I mean. There's an established infrastructure, and there's energy security. So the U.S. has its own coal reserves and mines and things. So there's an energy independence factor there. Um, and then employment. Coal plants create a lot of jobs. The cons are environmental impact. One major environmental impact of coal is mercury emissions and groundwater contamination from, failed ash storage systems and things of that nature. Those result in health risks to the general public. There's a negative view of the land degradation from coal mining, from kind of the I guess you would call them less responsible methods of coal mining. Water pollution, I mentioned. Waste management, again, is dealing with the ash from coal is a little bit of a challenge to do it responsibly. It's a finite resource just as a fossil fuel. It's not renewable. There are regulatory challenges, which is probably the biggest challenge with coal. It's becoming to where it's not really cost effective for new plants. If you're building a new plant, you're probably not building a coal plant. Um, and the efficiency, I don't know if I completely agree with efficiency, but it's going to be lower than natural gas or propane or something like that. But coal boilers are still fairly efficient. The next fuel, propane gas. So propane is similar to natural gas, but it is a little bit of the more heavier constituents of gas. So instead of being primarily methane, it is mostly propane with a little bit of butane, typically. So you can see that the HHV is about 2.5 times of that of natural gas. It's obviously stored under pressure for its in its liquid state. We're all familiar with buying propane for grills and things like that. Um, and this picture here is actually in my first job out of school. I worked for a company that did propane equipment. I designed this propane vaporizer here, and or this line of vaporizers. This is not a custom unit, but I designed this line, and then when I was doing a system assessment, recently I ran into it in the field. So I thought that was interesting. But this basically takes if you have propane and you need to use it in large quantities, you have to heat it. So that's another consideration of the fuel itself. There is a little bit of heating required to offset the Joule-Thomson effect as it expands and becomes gas. This is a water bath vaporizer that accomplishes that through running the gas through a heat exchanger in a water bath. And then the tank here is actually a surge tank for mixing. And so this is a synthetic natural gas system. So it vaporizes the propane and then it mixes it with air through these Venturi mixers, sends it into a surge tank, and that now is matching the properties of natural gas. And so you can blend propane with air to burn like natural gas and use it as a natural gas backup in the same burner and fuel train and all. So that's another advantage of propane. It makes an excellent backup for natural gas. So here's the pros and cons. So high energy density we talked about, reliability because you have a storage system right outside. Um, it's able to be stored and transported, so you can open a facility in a remote area and still be able to bring in propane and have your meet your fuel requirements. It's versatile, can be cost effective, widely available, and clean burning. I would say in a lot of cases, maybe even cleaner burning than natural gas. I think there's just less contaminants in propane usually. Cons, their carbon emissions. Price is typically higher than natural gas on a BTU or dollars per BTU kind of basis. Vaporization heat requirements we talked about. There's some health risks. One being that propane in its gas form is actually heavier than air, so it doesn't disperse as well as natural gas. So if you have a propane leak in a boiler room, you can actually have, kind of propane sitting or near the floor, not sitting, but, present near the floor in small quantities. And so people can be breathing that in without knowing it. I will say though that I spent a lot of time on test stands for those units that we were just talking about, and we would be wearing LEL monitors and the methyl mercaptan that they put. Methyl mercaptan is something they inject into gas and propane. It's that egg smell that you smell. It's so that you will be aware if there is a leak. That smell is not the natural smell of gas. It's a intended it's an intended thing that they inject into the gas for safety. Um, when I was on those test stands, you could smell that well before you were actually near the explosive limit of the gas. And so I found that to be a little bit comforting, and at least in home applications. I don't want to give anybody the wrong impression that they shouldn't be concerned if they smell gas, but um, hopefully you're not getting exposed to a bunch of propane without being aware of it. Anyway, on to the next fuel, biomass. So biomass refers to, it's kind of a general term that encompasses a lot of fuels. It's generally referring to solid wood and plant-based fuel, such as wood and wood residues, agricultural residues, and energy crops. Wood and wood residues, that's kind of self-explanatory. You're talking about anything coming from wood itself. Agricultural residues is really byproducts of agricultural processes, and then energy crops are grown specifically to be used as an energy fuel. Here are the heating values of each, just by category. There's some variance there, obviously. And you may be thrown off a little bit by this, like why is the wood so similar to the energy crops? That is an HHV in BTUs per pound. So if you think about how dense wood is, you're going to get, on a volume basis, you're going to get a lot more heating than you would out of energy crops. But if you are talking about on a pound, BTUs per pound basis, then it's a little bit closer. Biomass. Um, pros and cons. Yeah, there we go. So we're on pros and cons. So it can be cost effective, particularly if you are using a byproduct of your process. So in pulp and paper, it's often very hard to get efficiency measures approved because their fuel costs are so low. They're basically using free fuel. They will attribute some cost to it for handling and such, but and maybe how much they could sell it for if they didn't use it. But um, you're generally going to be half of the cost of natural gas. Um, and so that kind of hurts your ROIs when you're trying to develop projects. Um, anyway, it's a renewable resource over time, carbon neutral over time. So the idea is that the anything that you use can be replenished in a lifetime. Um, there's local economic benefits because you're buying your fuel from local sources. There's versatility in fuel types. A lot of biomass boilers can be designed to operate on different types of wood, as well as like you can even have like tires as a backup, like which we'll talk about in a minute, but shredded tires as a backup fuel for the same boiler, although that gets a little complicated. It does enhance energy security because again, it's locally sourced, and it does not require natural gas distribution, so these can be in remote areas. Cons, higher electricity consumption. There's a lot of fans and motors associated with these systems, from the conveying systems to the chipping. There's large hoggers that chip the wood up. You have truck tippers that will lift a whole semi truck to unload logs. This is a large system. You don't always have that, but and then the boilers themselves have multiple fans. The stoker grates have multiple motors on them, and so there's just a lot of electrical load. Um, anyway, the storage handling challenges. Um, Storage and handling challenges. The biomass can actually catch on fire as it decomposes, similar to, a hay barn. And so it has to be turned over regularly if you have a big stockpile of it. Um, yeah, so there's also high moisture content, emissions concerns, particulates, I would say, is the biggest. And then you still have carbon emissions, so there's still have to account for that. And then potential land use competition. There is large scale biomass production can compete with food crops or, for natural habitats. So that raises concerns about biodiversity and things like that. Then you have higher maintenance costs as well. And there's supply chain reliability. Where are you getting your biomass from? If it's from a particular logging operation that shuts down, then where do how do you replace that? So it's a not an insurmountable problem, but something to manage. The next fuel we'll talk about is hydrogen. So hydrogen is the most abundant element in the universe and is increasingly considered as a clean alternative for fuel for boilers due to its potential to significantly reduce carbon emissions. So it burns cleanly. So when you burn hydrogen with pure oxygen, um, the output is basically just water. This makes it attractive for applications where reducing greenhouse gas emissions is a priority. You can see there the HHV is about 290. If you remember, gas is about, we said is 1,020 BTUs per SCF. And there's three different types of hydrogen. So green hydrogen is referring to hydrogen that's produced with electrolysis using renewable electricity. So you take like a solar farm or a wind farm and use the electricity from that to create hydrogen. Blue hydrogen is created from natural gas processing, where they do some carbon capture. It's typically the strategy is to bury that in the ground, and that is how they're reducing the carbon emissions. But it's still does have carbon emissions. Gray hydrogen is really accounts for about 90% of the hydrogen used in the world right now. And this is the traditional method of using steam, methane reforming without carbon capture, and it results in high greenhouse gas emissions. So gray hydrogen basically is not eco-friendly at all. Green hydrogen is very eco-friendly, produced from renewable sources, and then the emissions are basically negligible. You split water up, and then you form water again. The bad news on this, it sounds great, right? But if you were to take renewably generated electricity, convert the hydrogen, and then use that hydrogen to fire a boiler, you would get about a third of the energy out of the boiler as compared to just using that renewable electricity. So there has to be some kind of outside factor driving this for it to make sense, whether that's a regulatory thing, maybe it's an energy storage thing, which it's, storing hydrogen is commonly talked about as a way to use excess electricity generated from renewables. It also makes sense in very energy intensive processes like in metal uh, processing and forging and things. Um, and so it does have its place. It's becoming kind of a buzzword. Maybe it's been a buzzword, I guess I would say. And I actually saw an article posted by B&W this week where the CEO Kenny Young, he said, if you look out 10 years from now, we see our technology standpoint demand switching a lot towards hydrogen. Hydrogen, we believe, will be in high demand in both the industrial and utility sector. So B&W is making investments to, in its corporation or whatever, in its infrastructure and assets to actually be able to generate hydrogen boilers because they think that this is a real thing. So it's not as pie in the sky as it used to be, but still not going to be an actual choice for most people installing a boiler next year, let's say. Pros, clean burning. We talked about that. High energy efficiency, reduces carbon emissions. Pretty much eliminates carbon emissions, I would say. Um, Cons, it's storage and handling challenges. It's low energy density, so you need huge tanks to get the same uh, amount of energy as you would through propane or even compressed natural gas or something. Um, Sulfur content is often in the gas. High production costs, we mentioned. Infrastructure adaptation required. So that's from your gas distribution lines to your fuel trains to your burner. Um, Kind of everything would have to be changed out, or your boiler, actually probably your whole boiler. And then safety considerations. So hydrogen is very explosive. Um, One thing that kind of offsets that a little bit is it is quickly dissipated. So we talked about propane kind of collecting as compared to natural gas. I read something that hydrogen dissipates 6 times faster than natural gas. So even though it is very explosive, a leak may dissipate and mitigate that danger pretty quickly. So that's kind of my overview of hydrogen. Any questions so far? Feel free to put those in the chat, um, and I will answer them. Next, fuel, renewable fuels. We're getting in the renewable fuels section. I guess hydrogen was a renewable fuel as well. Biogas. So biogas is a mixture of gases primarily composed of methane and carbon dioxide. So these are formed in digesters. So you're taking biomass, putting it in this process of anaerobic digestion, and then capturing the gas that comes off of that for to use. So that's kind of the gist of it. So we'll go through this. So feedstock is basically your organic material, such as agricultural residues, could be food waste, could be sewage sludge, animal manure, or energy crops. Anaerobic digestion is where you basically let the microorganisms break down the matter in the absence of oxygen. That's the anaerobic part within a sealed oxygen-free digester. Then you get your gas composition. This is usually about 50 to 70% methane and 30 to 50% carbon dioxide. So you can see it's about half of the energy content of gas per volume. natural gas, I should say. And then you go into treatment and or blending to deal with any sulfides, hydrogen sulfides that may be present. If you want to pre-treat those out, you might also blend it with natural gas to get closer and be able to use it in closer to the same properties and be able to use it in your existing equipment. Or you could blend it with propane, with a small amount of propane and try to create synthetic natural gas. And obviously that goes to wherever you're using the gas and the gas user. Here's another diagram of the process. You have different feedstocks, liquid organic waste, manure, dry organic waste, and that's all going into these digesters. And then the overflow goes, away for disposal. This is going to be used in a cogen unit where they're generating electricity and using the thermal energy in some process. Pros of biomass: it's renewable and sustainable energy source, reduces greenhouse gas emissions, local energy production, effective waste management, versatile applications. Um, and I will say it it still releases carbon emissions, but you're capturing those emissions on the front end. So you're capturing the methane that would have been released anyway, and sort of offsetting it that way. So that's kind of the benefit of it environmentally. Cons are the gas composition can vary. The feedstocks change, the digestion rate can change, and so you have to have some monitoring and oftentimes blend it with other gas to keep your properties consistent at your user. Energy density has a low energy density, so it requires larger lines and things for the same amount of energy. Infrastructure and costs. So setting up the biogas production facilities, digesters, and gas purification systems can be capital intensive. So and then maintenance and operational costs are also considerations. And then feedstock availability. So you have to be in a scenario where you're going to have a reliable feedstock. And then there's regulatory and safety considerations. But that's not really a disadvantage compared to other gases. Biodiesel is you're talking about vegetable oils being converted into biodiesel. Um, this usually involves mixing the vegetable oil with alcohol, and you produce biodiesel and glycerol as a byproduct. Biodiesel derived from vegetable oils is compatible with existing diesel engines and can also be used in boilers designed for liquid fuels. So B100 is a designation that means pure biodiesel. So you can have B20 is 20% biodiesel and 80% traditional diesel. There's the HHV values there. This is similar. If you remember the actual diesel HHV or fuel oil number two is 129 to 138,000 BTUs per gallon. So you're pretty close there. So you can actually use biodiesel in a lot of the same equipment. You could have a biodiesel as your primary fuel and use traditional diesel as a backup or something like that. So it's a pretty flexible fuel. We talked about how common diesel is. So this can be in a lot of applications, although I don't know that it's great on cost as far as the cost of the fuel. So the pros are that it's renewable and sustainable, lower greenhouse gas emissions, compatibility with existing boiler systems, is biodegradable and non-toxic, and provides some energy independence. Cons are its higher production costs, storage and handling requirements, cold weather performance issues, potential competition with food production for feedstocks, and which drives the price up, and then some emissions concerns, particularly like NOx and particulate matter. Next energy source is electricity. Electric boilers operate by converting electrical energy into heat through resistive heating elements or electrodes immersed in water to generate steam. So this is not a fuel per se, but just a different type of boiler to be aware of. And this is a realistic option, especially for smaller boilers. Like you see this one here. This is for a client of ours that was used to generate steam for an autoclave in a hospital. So the previous one is a large industrial electric boiler. Um, they made the comment to me that that boiler, when operating, had a bigger electrical load than the entire rest of the plant. And so they didn't really operate it that much, but there it is. But smaller electric boilers are pretty common. Um, and it's kind of an easy way to address a small load without having to run gas lines or those types of things. So um, they are a real option. Pros for electric boilers: high efficiency, no direct emissions. Oh, should I back up? High efficiency. Basically, an electric boiler is considered 100% efficient. So minus casing losses, 100% of the electricity you put in turns um, into heat. So it's pretty much 100% efficient. There's no direct emissions. You don't have any flue gas that you need to deal with. It's compact size and easy installation, quiet operation. They're pretty much silent and lower maintenance. Cons are higher operating costs. So um, this same client actually had us look at putting in electric boilers for their larger boilers, and the fuel costs compared to the electricity was going to be about a quarter of the cost. Um, so it's just using electricity to create steam is going to be about 4 times as much, at least in that specific application. If you have high fuel costs and very low electric costs, or if you have a renewable resource or a renewable electricity generation, then it starts making sense. Um, or if you have a very attractive incentive for reducing carbon emissions. So there's things that can make it make sense. Um, and that's what I'll say about that. Vulnerability to power outages are another con. Environmental impact, limited capacity for very large scale applications. I mentioned it often makes more sense for smaller boilers and can be high initial cost. That is referring to having to upgrade your electrical infrastructure in order to accommodate the load. Usually, the boiler itself is probably more expensive than your typical natural gas boiler, but then you're also going to have significant costs just upgrading your electrical infrastructure. Another so now with the electric boilers, we got in the alternative fuels section. Another alternative fuel is black liquor. So black liquor is, I'll just mention it quickly, but it's something that's generated in the craft pulp and paper process. If you ever hear of a craft paper mill, they're using this. Basically, they have this liquid called white liquor. It's used to cook wood pulp and separate lignins from the wood to create the pulp, or cook wood chips to create pulp. That drained liquor and organic materials becomes black liquor, which is burned in the plant's recovery boiler. So they usually have a large craft mill will have like a power boiler and then a recovery boiler. The recovery boiler has like a controlled environment for combustion, and so that they can collect um, the molten smelt. You can see that's this process here, which contains sodium hydroxide and sodium sulfide. So that is dissolved to become green liquor. The green liquor is purified to become white liquor again, and the whole process begins again. So it's actually a very efficient process, and it's a neat process to learn about if you want to look into it. Don't go into the pros and cons. This is very specific, again, to the pulp and paper industry, and not really an option for anybody else. And if you're doing this process, um, you basically uh, have to use your black liquor in order to regenerate. So Yeah, it's a very specific application. Next fuel is landfill gas. This is a renewable energy source formed from the natural decomposition of organic waste materials in landfills. So, um, food scraps, yard waste, paper, as they decompose again in an anaerobic condition within a landfill site, you can capture the methane off of it. So it's similar to biogas. It's just coming from a landfill. Landfill gas typically consists of about 50% methane. So you can see it's about half the BTU content of gas, natural gas. But it's a valuable energy source that can be captured and utilized to produce electricity, heat, and synthetic natural gas, basically. Um, excuse me. Um, Extraction systems, including wells and collected pipes, capture landfill gas for treatment and conversion into energy, mitigating methane emissions. So again, landfills are going to have methane emissions anyway, and you're capturing it and using it, offsetting natural gas requirements, and therefore reducing carbon emissions. And the pros are that it's a renewable energy source. It reduces carbon emissions. The fuel cost is low, pretty much free, because once your infrastructure is there, your fuel cost is free because it's just decomposing trash. And it provides energy independence and security. Cons are availability. It's a very specific application. There's variable composition of gas. You can imagine as the feedstock changes, also as the landfill conditions change, the gas composition is going to change somewhat, as well as the amount of gas coming out. Um, there's obviously huge infrastructure requirements. Environmental compliance is a challenge. There's a high initial investment, and there's some safety considerations. I will say that so leachate production or leachate management can be a concern with this, but I wouldn't say that's a con, because leachate is um, it's something that's formed in landfills, just due to the decomposition of organic materials. And it can contaminate groundwater. I wouldn't say that's a con of this, because it's something that has to be dealt with anyway in a landfill. So, but it can be increased due to, like, you're kind of encouraging the process of breaking the organic materials down, so the leachate can be increased. So there's a little bit more to deal with. Municipal solid waste. We're kind of getting close to the end, so I won't spend too much time on this. This is a very specific application. Fuel costs are basically free. As a matter of fact, my understanding is that most of these facilities actually make more money off of dealing with waste than they do off of the energy production from the waste. But this is obviously a utility scale type of fuel, uh, and so not an option for a lot of people. But it's basically burning trash, and it's going to be similar type of boiler to like a biomass boiler with other accommodations, so that you can burn the trash. Pros: reduces reliance on fossil fuel, diverts waste from landfills, locally available feedstock. Um, Promotes resource conservation. Sorry, I was looking at, I thought I saw a new poll come up, but it looks like what it's not. Um, Cons are emissions of pollutants. Variable composition affects efficiency. Again, just like the biogas and the landfill gas, you're going to have this isn't gas, but you're going to have a variety of different types of trash coming in with different heating values when it's burned. Um, Also, a varying amount of ash and byproduct from burning the trash. So it does require some pre-processing, so you can have a little bit more consistency. Um, and then public health and environmental concerns are there, and high initial and operational costs. Again, though, there is the advantage of you are making money by accepting the trash. So, and then you're getting a little bit more out of it by burning it. I would say it's not a great public perception because you're burning trash, but you're dealing with the emissions from that more effectively than if you were to just open air burn trash. Another fuel is tire-derived fuel or tire-derived aggregate. I mentioned this before. This is basically shredded tires that you can use as boiler fuel. So the pros of this, you get an energy recovery of the tires, offsetting some waste management. There's availability in a lot of places. It's widely available. High heating value. Um, Using tires promotes resource conservation by reducing the need for new fuels. So even though it's a pretty dirty process, you are offsetting some requirements of creating or processing new fossil fuels and kind of getting something out of the waste. Cons are emissions. It burns pretty dirty. Also has a lot of sulfur in it. So produces a lot of SOx and NOx emissions and volatile organic compounds. Ash disposal is a challenge. Handling is a challenge. It's you have to remove all the steel from the tires, or it will jam up your grates in your stoker boiler. So that is a challenge. Public perception can create a lot of smoke, and um, you know, nearby neighbors may not like it very much. And then there's a lot of regulatory uh, compliances that have to be met. And that's it. There are other fuels. I didn't mention nuclear steam generation. We do have a poll. That's not it for the presentation. Sorry, that's it for that section. I do have a little bit more to go through. And we got about 6 minutes left, so I'll go through that. There's a poll that's just released in the chat. What type of boiler fuels do you commonly see in your facilities? And as I would expect, you're going to see a lot of natural gas and fuel oils. I'm expecting a lot of votes for those. And we got some propane and some biomass. Yeah, so that's kind of to be expected. Any questions on that section? Go ahead and put them in the chat. I'm going to keep going though. So choosing the right fuel. So what are the considerations for selecting the right type of fuel? We've probably gotten a good sense of it just as we've talked about pros and cons of each fuel. You have fuel to heat costs, initial install costs, handling and storage costs, fuel availability or reliability, maintenance required, carbon reduction potential, emissions concerns, public perception and marketability, and long-term sustainability. So these are categories that I have come up with. I may be leaving something out. I took these and I did an exercise for this presentation where I put these in a weighted values matrix. So you have the different categories here: fossil fuels, renewable fuels, and alternate fuels. These are all the different fuels we talked about. I have electricity split into from renewable sources and from the grid. So you're just completely buying the electricity. Those are two very different scenarios. And so here for each of those categories, I've assigned each fuel a score, 10 being favorable, 1 being least favorable. So if you say natural gas initial cost is a 10, that's not high cost, that's a favorable cost. And then a weight for each category at the bottom. So all of that, you see the totals here. You can kind of see the results, but charted those here. Oops, went too far. And this is the result. So you see natural gas is still a pretty going to make sense for a lot of people. Biomass is pretty common. As far as this is for new boilers now, so coal, probably not going to be, not going to see that many new coal boilers in the current landscape unless things change. Fuel oils, fairly favorable. And then, you're starting to get like electricity from renewable sources. Again, this is me doing this exercise. This hasn't been vetted out by anybody else, but I think it's a good visual of just kind of a general perception of these fuels, at least from my standpoint. So, all that to say, before we lose everyone at the top of the hour here, what are your most realistic choices for a new boiler? So, if you are installing a boiler next year and you are just a general user of steam or hot water, what are your real fuel options, or most common or most likely fuel options? I would say natural gas is still number one, and then you're going to have some mix of propane, fuel oil, and biomass. And then people are realistically putting in small electric boilers. A lot of the other things we talked about were for a lot of the people on this call are going to be just educational. Landfill gas and waste boilers and things like that. Um, those are utility projects, so the average user is not going to be putting those in. I will say though that landfill gas and biogas, those things are injected into the natural gas distribution, so you may end up being a user of that gas just kind of indirectly anyway. So anyway, I really appreciate everybody joining us today. That's the end of the presentation. One thing we haven't mentioned yet, we do offer PDH certificates for the presentation. The process for that is just to email me after the presentation, and Ashley will put that together for you and send it over. Um, and that's our presentation. I didn't really leave that much time for questions, but I will hang on and answer any questions that I see in the chat. We really appreciate you joining us. We do have another SMI Presents webinar coming up in about 6 weeks, where Adam Keller from Myura will be presenting on boiler efficiency. So we'll send out some invitations for that, and we hope to see you at that. And again, I will hang out for a bit, and thanks for joining.